Okay, so since nobody can remember, let's talk about complex eigenpairs first. So this is example, it's 10.6 number 1, and I've got this matrix equation, right? So my plan is to, what with this thing?
A minus lambda I.
Yeah, I need to find the eigenpairs, right? That's going to be kind of my first jam. And then once I've found my eigenpairs, I've got this formula for an answer, right?
Yeah.
Okay, so let's find eigenpairs. So we're going to think about this as a matrix A, and we're going to do the determinant of A minus lambda I, and we're going to set this equal to 0. Yes? Okay, so that's going to be the determinant of minus 1 minus lambda, 2 minus 5, 5 minus lambda, set equal to 0. Yes? Which is going to give me a little quadratic equation. So I'm going to have negative 1 minus lambda times 5 minus lambda plus 10
Oh yeah.
equals 0.
Yeah.
Okay. Then I need to FOIL. So I got negative 5 minus 5 lambda. That was, oh crap. How do you FOIL?
I don't know.
Good point. Plus lambda squared.
I always just draw the lines.
I have no idea how I just spelled
This should be
FOIL.
plus. This should be plus 5. No, negative 5 plus. Oh wait, how'd you FOIL? Negative 5 plus.
I did.
Lambda.
I did firsts,
Outer.
and then I apparently did inner,
Okay.
Yeah. Okay.
and then outer,
Okay.
and then last.
Oh what?
So I just can't spell. Sorry, my bad. FOIL's hard.
Find out, like, the hardest part of these sections has just been algebra.
Oh yeah. 100% of the time, the hardest part here is algebra, because you look the form up in the book, right?
Yeah.
So you're like, okay, so I got this, and then that's like lambda squared minus 4 lambda plus 5 equals 0.
Why is there a huge space?
Why is there a huge
Complete the
space? Because I'm going to complete the square. So I'm going to add 4 and
bro.
subtract 4.
Go. That's sick.
It is indeed sick. Much like our sponsor this week.
Great Shadow Legends.
Alright, so I have a lambda minus 2 squared plus 1 equals 0.
Oh, this is ours. Yeah. We did one. Okay.
Oh, you guys were the ones! Alright, so subtract, square root,
Yep.
solve, get lambda is 2 plus or minus I. Yes?
That's our thing.
Okay. If you're watching this video later, these guys did this earlier, so figure out the algebra. Okay, so I got this, and now I should be going to fetch eigenvectors. So I have my eigenpair, or my eigenvalues. Now I need my eigenvectors. Where do I get my eigenvectors?
Plug it in for lambda.
Good. So that has to get plugged in for lambda in here, and I need to augment, right?
Yep.
So go over here, and I go, alright, I have negative 1 minus the quantity of 2 plus or minus I. And it should be noted that I'm doing something just a tiny bit lazy here.
You're making.
I'm just going to leave the plus or minus in there. The reason for that is that I know that a complex conjugate pair of eigenvalues is going to give me a complex conjugate pair of eigenvectors. You guys with that? So I'm going to save myself a little ink here, basically. Let's see, and then I've got a 2 up here, and it doesn't actually matter on the second row, right? Why doesn't it matter what the second row is?
Same.
Yeah, because I made this matrix singular on purpose. If you're not in linear algebra class, but you are for some reason in differential equations, it doesn't matter because it doesn't matter. Trust us. We did a thing to make it so it didn't matter. So I got a 0, and this is augmented by 0.
Yes.
So my equation up here really says that I have, I suppose, negative 3 plus or minus I, right? times my x coordinate plus 2 times my y coordinate is 0.
Yes.
This is me finding a vector in the null space of this matrix. Right. Finding the eigenvector. So, what do I do with this?
We have a...
I would hot one it.
Hot one.
Hot
Yeah,
one.
well, it's,
Yeah, there's one free variable, right? And so you get to one hot the one free variable. Right? So you get to pick either x or y as 1, right? You see that?
You said there's one that we should, like, you should set one of them equals to one of them, so it's much fucking easier.
Yeah, I tend to set x to 1
Yeah.
so that I don't have to divide by a complex number.
I love dividing by
You guys with me on that? It's not that it's bad or impossible to do that, it just makes for confusing arithmetic. So, I'm going to set x to 1. So if x is 1, then y is
Negative that stuff over 2.
Yeah.
negative 3 plus or minus I over 2.
Yep.
Right? Okay, which means that my eigenvectors look like 1 and minus 3 halves plus I times 0 and plus or minus I times 0 and 1. Okay. You guys all with me on that?
Yes.
Okay, so if I'm following along with the book's formulation, right, I can now answer this question. You guys with me? So, if I'm following along with the book's formulation, it says that the answer to a question like y prime is a y with EigenPairs, and my EigenPairs are a plus or minus bi, comma, u plus or minus iv. You guys with me on that? So, an equation like this, with eigenpairs like this, can be solved by... You guys remember the formula in the book? Probably not, right? Yeah, I don't tend to remember the formula in the book either. So...
Is that what you asked us?
And now he's about to write it.
Yeah.
No, I'm going to guess and then I'm going to check.
Okay.
So I do have the book
I
open
do
over
that
there.
in tutoring, like, do you remember?
Do you remember?
Yeah, like,
The best tutoring
No,
technique.
seriously, dude.
no, yeah, like,
No,
I
but
don't-
yeah. But like seriously, like, do you?
Yeah, it's the best tutoring
Why don't we
technique.
take a look at your notes?
Yeah. What did your teacher say? Let's go look that up. Okay, so my recollection of this is basically that I'm going to get e's to the real bits, right? So I'm going to say, okay, there's an e to the at cosine bt. That's the like real part.
And then this imaginary.
And then there's the imaginary bit's e to the at sine of bt. You guys both saying that?
There's a big plus. Wait.
Oh.
Doing like football symbols over here.
I can't, man.
Oh,
Why are you doing this to me, man?
So the reason,
Oh.
I have a feeling it involves the eyes.
it does indeed involve the eyes, but I'm pretty sure that it goes like that.
That's disgusting.
Which is a little bit rough. So I'm just going to check, right? I'm walking over
Probably
to the book. Let's see, it's... Ah, damn it. I knew I had screwed something up. Okay. You guys want to know what I screwed up?
What'd you screw up?
Okay, so the real part, this guy,
Has plus.
has a
I.
U on this one, and a V on that one. And then this guy has a, that's gonna get a U and a V on that one. Pretty sure.
Oh, gotcha.
It's U on the, damn it. U on the sine one and V on the cosine. Okay, and now you're like, dude, how in the fuck are you supposed to remember that? Right? So, you get the option. You can either memorize this formula and then execute it. So let's execute this formula quick, and then I'll show you where it came from. Because I don't tend to remember this formula. I tend to just go get it every time I need it. Here I went and got it out of the book. If the book's not available, there's another way to get this thing. You guys with me? Yeah. No, it's not. It's not that hard. So, I don't actually really expect you guys to remember this whole thing. I'm going to expect that we're going to go look in the book. We're going to remember that it involves e's and cosines. Right? Yes? Good? Okay. So let me write this whole thing down in our case. So in our case, I have a plus or minus bi is in fact, what did I get?
Oh, what?
What did I get on the other side of the board?
Oh, that thing. That thing right there.
What were my lambdas?
1 negative
2 plus or minus 1i. Right? And my vector u plus or minus iv was
1.
that vector over there. So a 1 and a negative 3 halves plus or minus an I times a 0 and 1 half. Yes? Okay. So I just need to plug this stuff in, right? Relatively straightforward, but I do need a whole bunch of board space because this is a long thing. Is with me on that? So, we're like, alright. Okay, y equals, let's see, constant numero 1. And then I need an e to the, what's a? 2. So I need an e to the 2t, a cosine, what's b? 1. So a cosine of regular t. What's the vector u?
1, negative 3 halves.
Okay, 1 and negative 3 halves. Then we're subtracting, and we've got an e to the 2t, a sine of t, and what's the other vector?
0, 1.
Perfect. So that's y1, right? This whole thing.
Yes.
And then we need to add to this our second constant, and then very similar stuff, right? I have an e to the 2t, a cosine of t.
0.
Yeah, and then this vector is the 0, 1 half vector. And a plus an e to the 2t, a sine of t, and a 1 negative 3 halves vector. Guys with me? Check, done, solves these, right? What kind of behavior am I seeing here? Yeah, there's something oscillating going on, right? Like, it's pretty clear from the fact that I've got cosines and sines everywhere that there's some kind of oscillation going on.
Down because of,
Close.
or it's got some kind of
Yeah, there's some kind of friction component in this system. Are the e's going to tend to get bigger as time goes on or smaller?
So anti-damage?
Yeah, the e's have a positive exponent. They're going to tend to get bigger. Yeah, this is like an anti-damped spring
Yeah,
system.
will that word? It's not a real word. You made it up.
Shh.
Okay. I tried to
Every
read
word is
about
made up by someone.
anti-damping.
Actually,
I don't know how to.
do you know actually what they call dampening?
What anti-damping?
I'm not gonna say because your video's on.
Go
Well,
for
it's not that.
What
Yeah,
is-
I know what you're
Go
gonna
for
say,
it. You know, it's like a bad word. So,
Oh,
yeah.
they use the word retarding?
Yeah.
Yeah, because that's what the word
Word
retarding means.
Yeah.
I just didn't want to
That's
say
also why
it.
it's called wanted to read a wiki article about anti-damping, but it
Well, I
doesn't
just
exist.
didn't want to say it.
Okay, look, anti-damping is definitely a thing that people
What's
talk
the
about.
word? It's not
Anti-damping.
Yeah, no, they have it in the book, I think, right? Is it in the book? Anti-damping?
Low read.
No, I looked in the index.
It's
of
an
the book.
open source book. It can be in the book.
Hey!
Physicists
All right.
say
On your sonatic card.
So, hold up.
Exactly.
Any questions on this process, other than where the formula comes from? You guys good? Like, if you can look in the book and get the formula, you guys are good at executing this process? Okay. That, I think, is probably a decent spot to be. What is the actual hard part of this whole process? Other than remembering the silly
That's
thing.
what I was going to say. The algebra.
If you get into
Probably completing the square and foiling, honestly. Like, otherwise, this isn't so bad, yeah?
Yeah.
Okay, so let's go see where the formula came from.